Welcome to the Deep Dive, your shortcut to critical knowledge. Today we're getting into something pretty exciting. It's the next frontier of professional education, adaptive immersive learning.
It really is.
We've got a great stack of material here describing a platform it's designed to tackle one of the biggest challenges in high-stakes industries.
The cost of human error.
Exactly. The absolute necessity of getting it right every time.
That's right. Our focus for this deep dive is a platform called EON Genesis Core. It's a new AI-assisted virtual and augmented reality system.
Yeah.
And what the sources show is a complete overhaul of how people in really critical fields learn.
Right.
So our mission today is to pull apart what makes this tech so effective. You know, for knowledge transfer in places like energy, aerospace, healthcare, we're talking 17 different high-stakes industries where you can't afford a mistake.
It really sounds like a game changer. And this isn't just, a better simulator or a video game. It's about stepping directly into these persistent, photorealistic 3D worlds.
Fully dynamic worlds.
For task-based lessons. So our goal is to really uncover the key features, things like Gaussian splats, drone mechanics, and this radar score that deliver this incredibly high knowledge transfer efficiency, or KTE.
All while keeping real-world risk at zero.
Let's start with the why. Why was this even needed?
Well, it really comes down to a crisis of knowledge transfer in these industries.
Okay, so let's unpack that problem, because these are massive, highly capitalized industries. Why do they need something so radical?
Because what they're doing now isn't working well enough.
The sources are pretty clear on this. So much of the current training relies on these passive formats. Think about it teaching someone to operate a multi-billion-dollar oil rig with a PowerPoint.
Or a 30-minute video, or some generic online module. It's not enough when the stakes are that high. Rote memorization doesn't cut it.
Not at all.
Modern industry demands such high precision.
Yeah.
And the consequences of an error can be, well, catastrophic. You're looking at loss of life, huge financial penalties, environmental damage.
Major operational shutdowns.
Exactly. So you have this huge knowledge gap that passive learning just can't bridge.
It makes sense. I mean, you can read a manual about a deep-sea drilling pump all day. But that doesn't prepare you for the sudden alarm, the pressure spike, and needing to turn a specific valve in under 30 seconds while chaos is erupting around you.
Precisely. That context is everything. And that's what Genesis Core is built to solve. It moves training beyond static PowerPoints and even beyond traditional simulations that can't really handle that kind of chaos.
So it's a complete paradigm shift.
It is. The learner stops being a passive consumer of information and becomes an active participant. They're in an environment that is constantly dynamically challenging them.
And that gets us to the core benefit. This is interactive training inside these persistent, photorealistic 3D worlds that don't just look real. They feel and respond like the real thing.
You're not just watching a screen. You are in it. And every single action you take has a real, immediate consequence within that virtual space.
What's really fascinating, though, is that it seems to go beyond just the visuals. It directly addresses the psychological side of high-pressure work.
Yes. It actually manages factors that traditional training just can't. Things like time pressure, unexpected system failures, alarms going off.
Interruptions, all the unpredictability of the real world.
All of it.
So it's actively simulating stress, which has to be key for building resilience. But how do they manage that without it just becoming a frustrating, impossible video game?
So the sources point to two things here. An adaptive Socratic dialogue framework.
Yeah.
And these built-in stress modifiers.
Socratic dialogue. So the AI is talking to you.
It's questioning you. It's not just grading your action. It's asking about your reasoning. Why did you choose that valve first? Or what are you anticipating might happen next?
Wow.
And then the stress modifiers evolve the scenario based on your performance, on your mistakes, even on your curiosity. It mirrors the real cognitive load of a chaotic situation, but in a totally safe, zero-risk environment.
Which brings us to the tech itself. I mean, building a virtual energy facility that behaves realistically, that's a huge technical challenge. So how do they do it?
The secret sauce is really this blend of cutting-edge visuals and responsive AI. And for the visuals, they're using something called Gaussian Splat Rendering.
Gaussian Splat Rendering. Okay, that sounds incredibly technical. Break that down for us.
Sure. So think about traditional 3D models in VR or games. They use polygons, right? Little triangles stitched together to make an object.
Like a digital sculpture.
A digital sculpture, exactly.
Oh, yeah.
And it can look good, but it often feels a little artificial, a bit game-like.
Yeah.
Gaussian Splat Rendering just throws that all out. Instead of polygons, it renders the world using millions of tiny colored transparent points of light, or splats.
Almost like digital paint or dust.
That's a great way to think of it. It's like building the world out of points of color. The result is this instant photorealistic visualization. The sources literally say the environments are indistinguishable from reality.
And that fidelity is so important when a technician needs to spot something subtle, like a bit of corrosion on a pipe or a faulty gauge.
Absolutely. And then on the other side, you have the intelligence, the adaptability. The system fuses that visual world with AI, with mentorship tools, with these adaptive learning principles.
So the environment evolves based on not just what you do, but how you think.
Exactly. The mistakes you make, the things you explore out of curiosity, it all feeds back into the lesson.
The impact of that for skill acquisition must be huge. Being able to precisely replicate these incredibly complex scenarios, the inside of a nuclear reactor or a busy shipping port.
And that precision translates directly to real-world confidence, to less hesitation when it really counts.
But the learner isn't just left alone in there, right?
No, not at all. And this is a critical support feature the sources highlight for the instructor. It's called the split-screen model.
What does it actually look like?
It means the instructor gets a dual perspective. So they can see the learner's first-person view, what they're looking at, but they also have another view, like an overhead map or a system schematic.
Ah, so they have the full context.
The full context instantly. So the feedback is immediate. They can spot a hesitation, a wrong turn, and guide the learner in real time because they know exactly what that person is seeing and probably feeling.
Okay, this is where it gets really interesting for me. Imagine you're a learner stepping into, say, the virtual engine room of a huge ship. It's massive, it's complex, information overload seems guaranteed. How do you even know where to look?
That is a classic problem in 3D learning, the where do I look problem. Genesis Core has a very specific solution for this called drone mechanics.
Drone mechanics. So is there a little virtual drone flying around with you?
In a sense, yes. It's an AI-powered guide. It gives you precise navigational focus. It might use a laser point or annotations or visual highlights to make sure you are always focused on the critical component for that step of the lesson.
Oh, it just cuts through the noise.
It completely eliminates that anxiety, that wasted time of just searching around, which is absolutely key to maintaining focus when you're under pressure.
It's like having an expert floating right next to you, pointing a flashlight exactly where you need to look.
And that guidance is made meaningful by something they call a semantic tagging pipeline.
Oh, okay.
This basically connects every single object in the environment to the lesson narrative. So every piece of machinery, every valve, every switch, it knows what it is, what it does, and why it's relevant right now.
And that digital intelligence is what lets the environment respond, right? If I flip a switch, the system has to know what that means.
It does. And that's managed by the spatial DOM system. Now, DOM usually refers to web development, a document object model. Here, they've applied it spatially.
I see.
So this context-driven tagging lets the platform understand the significance of every single action. You flip a switch, and the spatial DOM knows that just cut power to a critical system 300 feet away, and it adapts the entire scenario, the alarms, the instructor's view, instantly.
So it's translating all this raw, photorealistic visual data into actual actionable knowledge.
Right. It's not just overwhelming you with visuals. And if you do make a mistake, which is honestly where the best learning happens,
Of course.
they capture it with the feature called Vision Bridge. It's basically an integrated screenshot tool. The instructor can instantly grab that 3D moment, circle the mistake, and give you this incredibly detailed, objective feedback.
So let's talk about the structure. Because it's one thing to build this amazing virtual world, but another to prove it's actually creating better, safer professionals. The sources say every lesson follows a pretty strict 6-phase learning framework.
And that framework is what turns all this interaction into measurable, reliable skill mastery. It's a very deliberate progression.
Okay, so the stages are progressive. It starts with lecture for the basic knowledge, then engagement, where you start interacting, then assessment.
To measure that initial comprehension, yeah.
And then the mission. This sounds like where the pressure comes on.
That's the test. Performing the task in a high-pressure scenario. And then they bring in the behavioral elements, like gamification, to keep you motivated and encourage practice.
And the final outcome of all of this is the radar score.
The radar score. It quantifies your success across multiple dimensions, not just, did you do the task correctly?
So this whole approach means the learning is always tailored to the individual. If you're acing the mission, the AI just ramps up the difficulty.
Exactly. It ensures you are always being challenged right at the edge of your abilities. No two learning journeys are identical, but they all lead to validated mastery.
I really want to dig into that measurement tool, the radar score. It seems so different from traditional testing. The sources say it measures success across 5 critical axes.
Yes, and this is where you see the philosophical shift. The 5 axes are focus, curiosity, knowledge, competence, and resilience.
Let's just pause on that. You're saying they measure and score curiosity
Mm.
and resilience alongside something more traditional like knowledge.
Yes, that's what's so revolutionary.
Why put such an emphasis on those softer skills?
Because in a high-stakes environment, failure is almost never due to a simple lack of knowledge. It's usually a breakdown in resilience under pressure, or a loss of focus while you're multitasking.
That makes a lot of sense.
So the radar score is designed to measure the things that actually define a reliable professional in a crisis. Curiosity, for instance, actually rewards you for exploring, for asking what if. It encourages a deeper understanding beyond just the task at hand.
It's such a profound shift. Traditional training is just, did you pass the test? Yes or no. This is asking. Are you growing? Are you adapting?
Exactly. The score emphasizes progress and growth, not some restrictive pass-fail line. It's continuous, nuanced progress tracking, which is essential for professionals whose careers depend on this.
It's about developing the whole professional, not just someone who knows which valve to turn, but someone who has the cognitive and emotional stability to do it right when the alarms are blaring.
The resilience, that's the key. That's what this whole platform is designed to build. A better human professional through a better virtual environment.
So when we pull it all together, what does this actually mean for the future workforce?
Well, EON Genesis Core is really about empowering people to succeed under the most extreme conditions. It's moving knowledge transfer from just passive absorption to active, safe, contextual interaction.
And the material confirms this is happening now. The visualization pipelines, the spatial DOM, it's already being deployed in sectors like energy and manufacturing.
And the ultimate benefit here, and this is a quote from the executives, is about creating an abundance in immersive learning.
Abundance, I like that.
It means professionals in all of those 17 critical industries can train smarter, perform safer, and just engage more deeply with their work. It's a direct assault on catastrophic risk. It's an investment in safety, in competence.
For me, it's that idea of measuring curiosity and resilience that really sticks with me. If success in your job training is no longer about passing a test, but it's about continuously measuring how adaptable you are, how you seek out knowledge in a crisis, what does that future workforce even look like?
It looks like a workforce that can innovate under pressure, that can recover from the unexpected. It's a generation of professionals defined by how they grow and master their craft, not just by what they happen to know today.
Us too. Until next time, keep diving deep.